Oh, hello everyone. Am I audible?
Yes, sir.
Okay. Guys, we have a last class. We wanted to complete. I think we have started 3D, right?
Yes, sir, we did. We are in distance.
Distance between two lines.
Yes, sir. Shortest
Had we
distance.
done had we done this angle between two lines?
No, sir, we
Ah,
didn't.
okay. Good. Okay. So we were waiting for Fatima, but I don't think she's joining. So let's start the class. So we have covered the two forms of line, right? Uh, and each form in two forms, I mean, two methods through which we can form the line. And each method has two forms, vector form and Cartesian form, right? So we now know what is the equation of a line, how do it look like in vector form, and how do it look like in Cartesian form, right? Now, after this, we can find out the angle between two lines as well. So let's say we have these two lines. So we have these two vectors, these two lines, and there's an angle theta between them. Right? Now, let's say this is a line L1, which is represented as R1 is equals to A1 plus lambda V1 in vector form, and this is line A2, which is R2 vector A2 plus lambda B2, right? Then the angle theta between them can be find out using the direction. Now we know the direction of line R1, or let's say line L1, and we also know the direction of L2. The direction of this line is B1, and direction of this line is B2. So cos theta would be equals to B1 dot B2 divided by mod of B1 into mod of B2. It can also be done in Cartesian form, right? So now if you know the direction ratios, what does direction ratios represent? The Cartesian part was the denominator part, right? So we can use that part and take the dot product with another line and find out the angle between them. Okay? So this is one part, and after that, let's say we can also find out the conditions for perpendicular lines and parallel lines, right? Because if lines are perpendicular, in that case, cos 90 will be 0. So B1 dot B2 will be 0. Or rather, we can say that dot product of denominator will be 0. Right? And if the angle between them is 0, that is, they are parallel. In that case, cos 0 would be 1, which is only possible if the two DRs are proportional. We can also see that. Now, after that, let's start with distance between two lines. Okay. Now, let's understand the types of line in 3D. Guys, we do know about the lines in 2D, but we don't know about the possible structures of line in 3D. So let's say this is a 2D, and let's say I draw a line here. So 2D is obviously infinite space. This is just limited space given to me. Otherwise, if I draw, let's say this line. So if I extend them, maybe they don't meet in the given frame, but they will meet somewhere, right? Because they are converging towards each other. So they will meet somewhere far away a point. And obviously, we don't have a restriction on space. So given the structure is 2D, they'll meet somewhere. Or either they can be parallel, either they can be parallel. If the distance between them, and if you find out this distance, and this distance didn't change over the time period, then they are parallel. Then they won't meet, right? So you can find out there are three possible structures. Either they'll meet, either they won't meet, or either they'll be lying on each other coincidentally, right? Now let's talk about the possible structures of two lines in 3D. So these three are obviously true, but there's obviously, there's a fourth possible structure as well. So let's say it's kind of skew lines, right? So guys, am I audible?
Yes, sir.
Yeah. So this is the structure of two skew lines. So it's a jar. So it's a 3D structure. And there are two lines given. Now they will not meet, right? And neither they are parallel. So these are two lines, one red and one blue. These two lines will never meet because the structure is such that they are going in opposite direction. The only possible point of their meeting was possible if they are coplanar. Coplanar if they lie in the same plane, if they lie on the same base, because they have a height difference, right? This height difference. Now, there are four types of structures for two lengths, and one is skew lengths. Now, when we talk about the distance, so the distance between two lines can be carried out in two ways. Either the lines are parallel or the lines are skewed, right? In all other cases, the line would be intersecting and the distance would be zero. So if the two lines are parallel, in that case the distance would be easy. And if in case the lines are skewed, in that case also we can find out the distance between them. And also one more point, that we can find out the distance between a point and a line as well, the perpendicular distance. We can find out the perpendicular distance from a point to a line. And also one more thing, foot of perpendicular. So I just wanted to know that what is in your syllabus. Do we need to cover foot of perpendicular and image of the point as well?
We have image of the point, sir.
Image of the point, got it. Right. So let's find out the distance between these two lines and then distance from a point to the line. And after that, foot of the perpendicular and image of the point. So let's say we have these two vectors coming back to this. We have these two vectors. These two lines R1 is equals to A1. Let's talk about scales. So let's put the distance between two skew lines first. Distance between two skew lines, the lines won't intersect as well as they are not parallel. So if the lines are parallel, in that case, their DRs would be proportional. Right? But in this case, their DRs would be different, and also the point would be different through which the two lines are passing. So let's say first line is R1, and this is A1 plus lambda 1 B1 vector, and then second line is R2, which is A2 plus lambda 2, or rather we can call it mu B2 vector. In that case, we find out the perpendicular distance, right? It means that the exact point through which they both were under each other. So that distance would be calculated as, if we write out the direct formula, so that would be cross product of these two DRs, because that would be the direction, right? Because that would be the perpendicular distance to R1 and R2. So cross product would give us the direction, and distance would be given by A2 minus A1. Right? So the distance between them this will look something like this. First of all, see it. And they will be passing through somewhere like this. This will be the perpendicular distance. This distance would be called the shortest distance as well. This will be the shortest distance between these two skew lines. Right? Otherwise, the distance could be, if you talk about the largest distance, then it would be infinity. Right? Take the two endpoints of the lines. So we can, the point is to find out only the shortest distance. Hence, the shortest distance will always be perpendicular. Perpendicular distance, PQ, would be calculated as B1 cross B2 dot with A2 minus A1 divided by B1 cross B2. So this would give the direction B1 cross B2 divided by mod of B1 cross B2. That is to give out the unit vector. So unit vector, what does unit vector do? Unit vector provides us the direction through which the vector is written. Hence the distance will be given as the direction dot magnitude A2 minus A. And this can also be written in the form of, Cartesian form. This was vector form. So if we talk about Cartesian form, we can write the same form as, let's say, two lines are x minus x1 divided by a1 is equals to y minus y1 divided by b1, z minus z1 divided by c1. This is line L1. And then we have another line as x minus x2 divided by a2, y minus y2 divided by b2 is equals to z minus z2 divided by c2. And this is line L1. So guys, always remember, you can practice this practice the whole lines through this. So you write two vector equation, you write two Cartesian form, and remember, try to memorize all the formulae from here. So distances, shortest distances, b1 cross b2 divided by mod of b1 cross b2, because that is the direction, because the direction is perpendicular. We are finding out the shortest distance that has to be perpendicular, and perpendicular would be that, how do you find out the perpendicular direction? By taking out the vector product of drs. So we are taking out the unit vector in the direction of perpendicular to both vectors, and the magnitude would be a2 minus a1, the points through which these two lines are passing. Now, in the form of Cartesian, if you talk about Cartesian form, so Cartesian form would be a2 minus a1 would be the difference between points. So this would be x2 minus x1, y2 minus y1, z2 minus z2. Right? X2 minus x1. So if also remember this. This is a form which is known as scalar triple product. Scalar triple product. So we haven't talked about it in vectors, but scalar triple product is also in the syllabus. And I just gave you the hint that we have four types of products. So which four type of product? One, two we have already studied, dot product and cross product. Another type is, third type is scalar triple product. So this is B1 cross B2 dot with A2 minus A1. Right? Let's understand the process. If A2 minus A1 is happening, then A2 minus A1 is basically the difference between points. So the difference between points will be what? X2 minus x1, y2 minus y1, z2 minus z1 with j cap, k cap, and I cap. Right? B1 cross B2 would be ijk, right? Ijk, then A1, B1, C1, then A2, B2, C2. This a determinant. This would be a determinant whose three rows would be first row ijk, second row A1, B1, C1, and third row A2, B2, C2. Right? And we'll get a vector we'll get a vector whose, we'll get a vector in which I, j, and k will be component, right? And we'll get some vector, okay, with I, j, k component. Now, after that, if we find out dot with a2 minus a1, then we are what are we doing? We're just multiplying subsequent I, j, and k. X2 minus x1 with whatever we get with I, y2 minus y1 with whatever we get with j here, and z2 minus z1 there, whatever you get with k. Okay. So, just a minute. So instead of doing this lengthy process, what we can do is we can write out this whole scalar triple product in the form of a determinant, whose three rows will be replaced with ijk will be replaced with x2 minus x1, y2 minus y1, and z2 minus z2. Because that will be the ultimate result. Yes, did you get it? Rather than doing this process as okay, let's find out this. B1 plus B2 would be ijk, then A1, B1, C1, then A2, B2, C2, right? And if you solve this, what do you get? B1, C2 minus B2, C1 into I cap, right? Minus J cap. And with this, you'll get A1, C2 minus A2, C1 plus K cap. You will get A1, B2 minus A2, B2. And if you find out A2 minus A1, so that would be x2 minus x1 I cap plus y2 minus y1 j cap plus z2 minus z1 k cap. Now, if you take the dot product, what you are doing? You are multiplying x2 minus x1 with this b1 c2 minus b2 c1, then plus minus minus y2 minus y1 into a1 c2 minus a2 c1 plus z2 minus z1 into a1 b2 minus a2 c1. So instead of I, j, and k, you just replaced x2 minus x1, y2 minus y1, and z2 minus z1. So instead of solving this, if you solve x2 minus x1, y2 minus y1, if you replaced first row with x2 minus x1, y2 minus y1, z2 minus z1, this given determinant would have given you the value of directly this scalar triple product. So scalar triple product can be directly solved through this determinant, with first row as dot of 1, and second row and third row with the rows of cross product. Okay. So this can be directly given as and also notice that the value of this determinant would be a constant. and the dot product is also a constant value. So this can be directly written in the form of this, and B1 plus B2 would be the modulus of P1 and B2. I mean the cross product of P1 and B2. That would be easy to find. I mean, not easy, calculative, but easy. But yes, you can make mistakes there. Now let's find out the distance between two spin lengths through an example. By the way, the distance between two parallel lines is pretty simple as well. So let's say, let's study that as well. After that, we'll go to example. Can I do this? Okay. So second one is distance between two parallel lines. Also understand the figure of parallel lines too. The parallel lines would be this and this. They will not be in same phase. I mean, there will be some distance that would be constant throughout, and they'll have same structure of plane. I mean, same direction, but the points will be situated much higher. This is line L1 and this is line L2. This distance will be same everywhere. D, 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 D. So this would be a parallel. Now, if the distance is same, hence the direction is same. So this is a point, I mean, this is a line which is passing through some point A1. Right? And with lambda coordinates of some vector. Then this point will be passing through some other point A2, but with same direction. Now, same direction, maybe with different coordinates. Direction is same. Hence, the distance between them can be found out using the B, this direction B, and the distance between A2 and A1. So this would be, if we talk about in the form of vector, so D would be A2 minus A1. Now we have only one other variable. Before we had B1 and B2. Now we have only B. So the direction, I mean, the direction, perpendicular direction can only be created using the help of A2 minus A1 and B. So A2 minus A1 cross B divided by mod of B. A2 minus A1 cross of B divided by mod of B, and the whole of this A2 minus A1. And if you talk about in the form of Cartesian, then A, B, and C would be same, right? And A2 minus A1 would be replacing second row, let's say, ijk would be in the first row, and then whatever we have, we find out the modulus of that value divided by modulus of p would be the answer. Right? We can understand more about both of these two distances through some examples. Let's consider one of the example. Can I remove this?
Yes, sir.
So let's come to the exercise 11.2, page number 477. And yes, we have solved. We haven't solved. No. Find out these two. Okay, let's talk about come on page 478 and see the question number 14. So we have to find the shortest distance between the lines. We are given two lines. Okay? Now, one tricky part is this is a simple part, but tricky that they are just given find the shortest distance between these two lines. Now we don't know whether these two lines are parallel or not. Right? So because we have to formula. So how do you find out which one to apply? So you have to understand whether the lines are parallel or not. So can you understand that? And tell me what do we need to do in question number 14?
So if the lines are parallel, then the b vector will be same. But in this case,
Yes.
both the b vectors are different.
Okay, correct. So we have to apply the formula for skew lines. Right? Find out the distance between them. Find out the shortest distance between these two. Yes, can you help me understand this? First of all, the numerator part. So we have to apply a determinant to solve that scalar product. Right? So the first row of this determinant. I have to apply the formula B1 cross B. Okay. Dot with A2 minus A. Yeah, so what would be the first row? First row would be A2 minus A1. What is A2 minus A1?
I minus 3j minus 2k.
I minus 3j minus 2. minus 4k.
Yeah, minus 4k.
I minus 3j minus 4k. So I minus 3j minus 4k would be mean. It means that 1, okay, coordinates of this 1 minus 3 and minus 4. Then what would be the second one? 1 minus 3, 2. And the third would be 2, 1, 2.
2, 1, 2.
So the 2
B1
direction
cross
issue.
B2 is
Yeah.
minus 3i plus 3k.
Minus I. Sorry. How did we get that? What would be B1 cross B? Tell me again.
Minus 3 plus 3k.
Okay, you have solved it.
Yes, sir.
Okay.
B1 cross B2.
B1 cross B2 would be. Sorry, tell me again just once. 1 minute. Just repeat the value once. What would be the modulus of it?
3 plus 3. 3 square plus 3 square. That is 20. 9 plus
18.
9. That is root 18.
18. Okay. So that would be the shortest distance between these two lines. And that can be calculated as 1 into minus 6 minus 2 minus 8 plus 3 over 2 should be 2 minus 4 minus 2 plus minus 4 would be 1, and that would be plus 6. 1 plus 6 would be 7 divided by root 8. Means the distance would be minus 8 minus 6 minus 28. We will take them all, obviously. Minus 8 minus 6 minus 14 and minus 28 would be minus 42 divided by root 18. So 42 divided by root 18. And also write this root 18 as 3 root 2. Means we can write it as 14 by root 2. Or rather 7 root 2. That would be the answer. Okay. Find the shortest distance between the lines given in 15th. Solve 15, 16, 17. Solve all of them. 15, 16, 17. These questions are interesting. Everyone is unique in their own way. Hence, we need to solve all of them because you'll understand this better. And only after that, you'll be comfortable with the understanding of photo probability as well as image of the point. Okay. So this will certainly help us in that aspect as well. So in 15, just tell me first, what would be the shortest distance? I mean, which formula we need to apply, whether the lines are parallel or not. Skew lines, parallel lines. Yes, guys. Skew lines or parallel lines? In 15th.
Skew line, sir.
Skew lines. So in numerator we will have one of these determinants, which would be what? 4, 4, then again 4, 6, 4, 6, and 8 will be the first row. Then 7 minus 6, 1, 1 minus 2, 1. Am I correct? This
Yes,
would be
sir.
the determinant. And divided by root over root over. So I'm directly calculating the modulus. So that would be the cross product of those vectors, which would be b2 minus b. I mean b1 c2 minus b2 c1. Calculated according that b1 c2 minus b2 c1 square plus. Then again we have to multiply a1 c2 minus a2 c1. Then a1 b2 minus a2 b1. Okay. So you can find out the distance using that. Let's find out 16th as well. Tell me 16th. For 16th, whether the lines are parallel or skew.
Skew line, sir.
And how do you find out for 17th? How do you solve for 17th? What are the DRs of first line and second line? First of all, find the DRs. Now, how do you find out DRs? Well, guys, what is T and what is S here?
They are the lambda and mu. We
Yeah.
can open the bracket of this equation and
Yes.
take up those products which are having t, and you
Yeah.
will get in the form r is equal to a1 plus t b1.
Yeah. Correct.
So
So
similarly, you
T
can
and
do
S
for
are
the
the
next equation.
parameters.
Yes,
Yeah.
sir.
Correct. So these T and S are known as parameters. Okay? They are just what are they doing? They are just scaling your direction. Okay? So T and you can take all the T together and take all the S together in the second equation to find out the DRs. And then what did you notice? Whether the lines are parallel or skew. In the first one, this will be -1, -2. No, sorry, -1, 1, and -2. -1, 1, and -2. Okay. The second one, this would be 1, 2, and -2. 1, 2, and -2. So are they parallel or skew?
Skew line.
Skew lines, right? Because you see that this is 1, 2, and -2. Okay, they are same. This ratio is 1. This is 1 by 2, and this is -1. Okay. or parallel skew. Hence, all of them just tells you how to understand the equation flying in a better way, right? Because the equation are given in vector form, Cartesian form, and then one is twisted form. Okay. Now, can you find out 10th first part? You have to find out the angle between the two lines. The pair of lines is given. You have to find out the angle between them. 10th first. Tell me the value of cos theta. What's the value of cos theta? How do you apply the formula? Value between two lines.
Cos theta is equal to modulus of b1 dot b2 by b1 modulus of b1 into modulus of b2.
Correct. So b1 dot b2 will be what?
19.
19, correct. And mod b1 is
7.
and mod b2,
3.
correct. So it should be 19 by 21. Can you so guess on 11th first part? So am I reading the question correct? Because it's no, it's not 11th first part. I want you guys to solve 11th second part. 11th second part and the angle between the whole pair of lines. And am I reading the question correctly? Because I'll be solving with these as well. So the second part will be x by 2 is equals to y by 2 is equals to z by 1. And x minus 5 by 4 is equals to y minus 2 by 1 is equals to z minus 3 by 8. Is the question correct?
Yes, sir.
Good. Find out the angle between these points. Guys, sorry. Can we just paste this equation? So what are we doing is we're writing as let's say this is minus x by 2 is equals to y by 2 is equals to z by 1. Right? This is the first equation. And the second
So
one
it's
is
just x by 2, right? Not minus x by 2.
no, it is minus x by 2. We are actually transforming the equation. I want you guys to find out the angle for this because they haven't given the they aren't given the good question. This is a rather simple one. This is a good question. Change it to minus x by 2 is equals to y by 2 is equals to z by 1. And change this part as well as minus x by 1. This is just x minus 5 divided by 4 is equals to y minus 2 divided by 1 is equals to z minus 3 divided by 8. Also changing this to minus z. The other minus z plus 3 by 8. Minus z plus 3 by 8. These two equations are given to you. You have to find out the angle cos theta. Very good. Okay, what's the value of B1 dot B2? What is B1 B2? Let's first find out this A1, A2, and B1, B2. So what is A1?
0i plus 0j plus 0k.
Yeah, 0 is 0. Right? And what are the values for B1?
B1 is minus 2i plus 2j plus k.
Yes, minus 2, 2, and 1. Now, those would be the coefficient. Right? And what is the value for coefficients for A2?
It's 5, 2, and minus 3.
5, 2, and minus 3. And no, 5, 2, and 3. If you take minus common from minus z plus 3, take negative to the denominator, that would become z minus 3. So the point would be A2 would be 5, 2, and 3. And B2 would be 4, 1, and minus 8. Right? And B1 dot B2 would be minus 8, right? Minus 8 plus 2. Minus 8 plus 2, minus 8. Minus 8, minus 8 plus 2. So minus 14. So 14. Okay. Divided by root over 4 plus 4 plus 1, 3. Into 16 plus 1, 17 plus 64, 81, 9. So this would be 14 by 26. Okay. After 11th, can you please also solve 12th? Find out the value for B. What needs to be done to find out the value for B? Tell me that first. It's given that the lines are perpendicular. If the lines are perpendicular, in that case,
A1, A2 plus B1, B2 plus C1, C2 is equal to 0.
yeah, correct. So A1, A2 plus B1, B2 plus C1, C2 needs to be 0. So what's the value for A1, B1, and C1, and A2, B2, and C2? Next step is to find out that. What is A1, B1, and C1? This should be -3. Right?
2p by 7 and
2p by
2.
7. 2, right? What would be the value for A2, B2, and C2 for second part?
A2 is equal to -3p by 7.
Okay.
B2 is equal to 1 and C2 is equal to -5.
Okay. And then we can find out the value. Okay. Right. So understand. Just find out the value for P. And Shan, are you available? Are you listening to me? Guys, when do you start? I mean, when do you guys have your exams for boards? Did you receive
Our
any notification?
yeah,
Yeah.
pre-boards, our second pre-boards are starting by this Monday,
Okay.
this week.
And when will the boards start? Boards will be. Has the date sheet come?
Yes, sir.
Yeah.
Both. It starts with English on 24th for us.
Okay. 24th Feb, right? Yeah. 24th March.
February.
Okay, let's first understand what is photoperpendicular and for perpendicular distance and image of a point with respect to a line. So try to tell you this with a vector as well as Cartesian form. We have, let's say, this point as P, which is x2, y2, and z2, right? And we have the equation of line as in vector form as a plus lambda b, which can be written as in Cartesian form as x minus x1 divided by a is equals to y minus y minus equals to divided by b is equals to z minus z1 divided by c, right? Now, if I find out the shortest distance from this point to the line, right, then that distance would be perpendicular. Okay? And let's say that shortest distance is PQ, some point at Q. Then that point Q is known as photoperpendicular, because that will be the feet of perpendicular, right? I mean, that is where perpendicular lies, bottom of perpendicular. So x3, y3, z3 will be the photoperpendicular, and let's say we see if you take this mirror, if you take this line as a mirror, then the reflection of P would be some P dash. Reflection of P would be defined as P dash, image of P or reflection of P. And the coordinates are defined as x2 dash, y2 dash, and z2 dash. Right? Now to find out P dash, we must find Q. Now, if you can find Q, because you can find out Q easily, and if you find out Q, then after finding out Q, you can easily find out P dash. Because Q will be the midpoint of P and P dash. No. It's a plane mirror. The distance of object from the mirror would be equal to the distance of image from the mirror. Right? Hence PQ is equal to P dash Q. Q would be the midpoint. So once you find out Q, you can find out P dash easily, right? By applying the midpoint formula. And Q can be found out in the later on slides. Guys, have you made this?
Yes, sir.
Okay. So second slide is, this is some vector form of P point, which is alpha bar, let's say. So this is alpha vector, which is x2 I cap plus y2 j cap plus z2 k cap, which we have already defined in the last slide. And let's say we have this line r is equals to a plus lambda b, line z, right? And some point is q, which is photoperpendicular, known as beta. Now we know the coordinate of beta is x3 I cap plus y3 j cap plus z3 k cap, as we have defined in the last slide. A general point on L, any point on this L, can be taken as a plus lambda. No, because this line, how did you represent this line? You represented this line as that, let's say R is some point on this line, then that some point can be represented as a plus lambda b. That is how you define the line. A point, to define a line, a point is needed. This was the point, and this is the direction of line. So to define a line, you need a point and the direction of line, and you know that every point of the line must be passing through a plus lambda. So a general point in L can be taken as a plus lambda b. Now, if you take beta, this general point, which is the photoperpendicular as well, that can also be expressed as a plus lambda b. Right? So any general point on given line is a plus lambda. Now, angle between PQ and L, angle between PQ, this line is PQ, and this is L, is 90 degree. So dot product of the DRs must be 0. Okay. So dot product of PQ would be PQ, right? Can be found out using PQ, point P and point Q, which is beta minus alpha, right? Beta minus alpha. And dot with B. Dot with B is the DRs of line. So line DR and PQ DR must have a dot product equal to 0. Now this beta, we have already written this beta as a plus lambda. A plus lambda minus alpha bar dot p 0. So this can be written as a minus alpha dot with b plus lambda time mod b square, b dot b. B dot b will be mod b square. So the value of lambda, this lambda, can be calculated as alpha minus a bar. Alpha minus a bar would be what? This point minus the point that is lying on the line. Point which for which you are finding out the photo perpendicular, that point minus the point which is already lying on the line, dot with the direction of line b divided by mod b squared. That is how you can find out the value for lambda, and that specific lambda will give you this value for beta. I mean, this is a general point right now. This will exist for some value of lambda. If you keep changing the value of lambda, you will get every point on this line. If you just keep changing the value of lambda, this will cover the whole line. That is the point. That is how the equation is defined, that you just keep changing the value for lambda. So we know that for some value of lambda, this point has to be beta. We are just finding out that some value of lambda. So that value of lambda can be finding out using this. And that is how you got your point beta. How? Beta is A plus lambda b. Beta is equals to A plus lambda b. And now you have the value for lambda. So you put it here and you get the value for beta vector. That is the point. Guys, did you get it?
Yes, sir.
Can we proceed if you have written? Okay. Just raise your hand. Anyway. So let's talk about the same process in Cartesian form. So this is just for the understanding purpose. General point on line L is x1 plus a lambda. That is how you can express this. You can equate all of them using a lambda. Lambda is that parameter for which the point is defined. So general point is xyz, right? So you're putting the value of xyz. How the value of x? You're putting the whole ratio equals to lambda, because for some lambda that point will exist, and x is found out using a into lambda plus x1. We are just equating these two lines. So you get x is equals to a lambda plus x1. Similarly, y is equals to b lambda plus y1. And similarly, z is equals to c lambda plus z1. Okay. So general point of this line L is this. You have to find out that particular lambda for which this point q can be defined. So drs of pq into dot of drs of L must be 0. Drs of L we know a, b, and c. Drs of pq would be what? x1 plus a lambda minus x2 into plus y1 plus b lambda minus y2, and similarly this process. Now just arranging them, that is a difficult task. That is why I have done it already. So you can multiply that a with x1 minus x2, and if you take them to the right hand side, this will become x2 minus x1. So a into x2 minus x1 plus b into y2 minus y1 plus c into z2 minus z1 would cancel out these parts. The only parts are left are these. So this will become a square. This becomes b square. This becomes c square. This is in the denominator because this is with lambda. So this will go in the divide. That is how you can find out the value for lambda. And now put value of lambda in general point. Put the value for lambda here. Find out the value for x, y, and z. Because that x, y, and z is the point key. That is for the perpendicular. And then find out the PQ distance using the distance formula. Okay. And similarly, you can find out the point P dash, which is the image of the point. Can you proceed to the next slide, which is the last one? Yeah, part of the question. Okay, so if L, M, and N are given, in that case, the value is given, and also the point formula. So this is pretty basic. If L, M, and N are given, then you can directly use this formula, but this is a big formula, so it's not. Let's not remember the formula. And if you're good with formula, you can write this. If L, M, and N, DCs of given line, then the distance can be directly find out using this. X2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square minus L times x2 minus x1 plus m times y2 minus y1 plus n times z2 minus z1, where x1, y1, z1 is the point on the line, and x2, y2, z2 is the point from which we are finding out the distance, right? Okay, so let's solve some given questions. I want to mislead this exercise. I guess we will only get questions from this particular part in this lines. Oh, I don't think we have questions from photo perpendicular and image in miscellaneous exercise as well. Though you can solve question number 20 on page 499. Can you guys solve this? It's given, find the vector equation of the line passing through the point 1, 2, and minus 4 and perpendicular to the two lines x minus 8 by 3, y plus 19 by minus 16, which equals to z by z minus 10 by 7. Did you find the question? Question number 20. So you have to find the equation of a line which is passing through 1, 2, minus 4 and which is perpendicular to the two lines. Perpendicular to the two lines, meaning you're given these two lines, you have to find out a line which is perpendicular to both of them and passing through a point. So how do you do that? Point already given. For the direction ratios, how do we find out the direction ratios of the line? To write the equation of line, we need two things. Point is already given. You have to find the DRs. Nazia, Sakina, do you find the question, guys?
Yes, sir.
Okay. So planes is lines are given. You have to find out the perpendicular line. How do you find out a line which is perpendicular to both two lines? So let's say we have this line as L1, another line as L2. They are intersecting. And this is, let's say, some of the dr is d2. It's dr, direction issue, right? And this dr is v1. Then that line, which is perpendicular to both of them, right? So a vector product of both of these lines. If you take the vector product only signifies the perpendicular direction. So the direction of your line, can we find out? Yes, can we find out? V1 cross V2 divided by V1 cross V2. We need to take unit vector, right? DRs would be just V1 cross V2. And if you take DCs would be V1 cross V2 divided by mod of V1 cross. Now you have both of their DRs. So you can easily find out the DCs as well as DRs. Can you tell me the equation? This would be something like this. Just fill out the blanks. X minus 1 divided by y minus 2 divided by equals to z plus 4 divided by this is, if you notice, is the value for V1 cross V2. In which you can take out 12 common. So this would be 2y plus 3j plus 6 7. So this would be 84. Total would be 84. Okay. So if you divide it the whole by 84, so this can be written as 2 by 7. Yeah. Divided by 3 by 7. Divided by 6 by 7. If you write in the form of DC. And if you write in the form of DRs, you can just write 2, 3, and 6. That is how you can write the equation of them. Okay, so we have to solve some questions on these topics, which we'll cover in the next class. Right? So guys will complete the whole syllabus in the next class. You can come with your problems, whenever you want. We can arrange the extra class as well. Okay, so solve all of these problems. Now start solving, more and more problems. Come with your doubts. I want to see some of the doubts. We'll get. Okay, so the class is over for today. Stop it.
Thank you, sir.
Thank you, sir.